Good evening, ma'am.
Yeah, good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening. I've shared my screen. It's visible, right?
Yes, ma'am.
All right. Okay. Why Netra online today?
Ma'am, I came to my grandparents' house, ma'am.
So you're not in town. All right, fine, fine. And Srijana, every time you ask me, like if there is physical class, but you're joining online, why you're not coming for the physical class? Srijana.
Next time I will go, ma'am. My father is not here.
What?
My father is not here, ma'am.
Okay.
Next time I will try to come, ma'am. Next time I will come, ma'am.
No, like earlier also, sometime you did not join the classes because you said you will come when I start physical classes.
Yeah,
In the
ma'am,
middle, yeah, for some time, you did not take up the classes. You said you will come when I start the physical classes. So
Sorry,
I'm
ma'am, I will come, ma'am.
Yeah, I'm expecting you every day, but you're not turning up. Okay. Children, in this one, 1, 2, we finished, right? Have we finished the third one in this one?
Yes, ma'am. We finished writing all of those and we have to explain only the fourth one, ma'am.
Correct. That's what even I remember. We finished all the 4 and I have to explain only the 4th one. Third one we did in the class. You don't remember? Okay, fine. Okay, I forgot the class here. Good evening, boys. Good evening, Raja and Arjun. Okay, so we'll start from the third one. Okay, fine. Some of us want the third one, so I'll do the third one and then the fourth one. Okay, so here it's given that the length of a classroom is 2 times its height. Somebody's mic is enabled. Please disable your mic. Length of a classroom is 2 times its height. So see here, length is equal to 2 times its height, 2h. And its breadth is 1.5 times its height. Breadth is 1.5 times its height. So what is the breadth? 1.5 times. 1.5 times meaning 1.5 into height. So 1 by 2 h. Which is 3 by 2 h because 1 by 2 is 3 by 2. 3 by 2 h. And what is the height? Because you have the length here 2h. Breadth 3 by 2 h. What's the height? H. Height is h. Now, so we've read the question till here and we've done the assumption. Length is twice the height, breadth is 1.5 times the height, and the height is h itself. Now read ahead. The cost of whitewashing the walls at the rate of 1.6 rupees is rupees 179.20. So what work is done here? Whitewashing. The walls are whitewashed. The walls are whitewashed. So how do you find the cost of whitewashing? Whatever is the area of the walls multiplied by the rate will be the total cost. Area of the 4 walls. Why area of 4 walls? Because 4 walls only are whitewashed. So the area of the 4 walls. See the board? Area of 4 walls. See the cost of whitewashing is given to be 179 rupees and 20 paise. How will you find the cost? Cost is area into rate. Area into rate, and area is area of 4 walls into rate is equal to the total cost. And how do we find the area of 4 walls? 2h into L plus B. Rate is 1.6 rupees. Total cost is 179.2. So now let's substitute 2h into L plus B. H is h, L is 2h, and B is 3 by 2h. is equal to this one divided by 1.6. 1.6 goes for division to the other side. So now when you take the LCM, 2 plus 3 by 2. 2 plus 3 by 2, on taking LCM, you will get 4 plus 3, 7 by 2. LCM, 7 by 2. So 7 by 2 H or 7H by 2 is equal to, shift the decimal point. You're shifting 1 in the numerator, 1 in the denominator. Shift 1 point in the numerator, 1 point in the denominator. So it becomes 1792 by 16. So now 2 and 2 gets cancelled. 7H into H is 7H square is equal to, on simplifying this, 16 ones are 16, 112 times. You don't have to use 16 tables straight away. You do with 2 tables. So it simplifies to 112. So H square is equal to 112 by 7, which is 16. So H is equal to square root of 16, which is 4. So now you can find, after finding H, you can find 2H, which is the length, and 3 by 2H, which is the breadth. Now we have to find, so now we have found the dimensions of the classroom. We found the dimensions of the classroom, the length, the breadth and height we found. Now we have to find the cost of tiling the floor. Tiling the floor. So you should find the area of the floor. To tile the floor, you will have to find the area of the floor. So cost of tiling the floor is equal to area of the floor into rate of tiling. The cost of tiling is equal to area of the floor. Why area of the floor? Because tiling is done on the floor. So you'll have to find the area of the floor into the rate. How do you find the area of the floor? It's a rectangle. Floor is a rectangle. So L into B. H will not come. Area of the floor, rectangle, L into B. Into the rate. So length and breadth we already know, 8 and 6. Into the rate, which is the total cost. All right. A storage tank is in the form of a cube. When it is full of water, the volume of the water is 15.625 meter cube. So it's a cubical tank. It is a cubical tank. So what is the, how do you find the capacity of the tank? A cube. A cube. Capacity of the tank is A cube. And that's given to be 15.625 meter cube. So the capacity of the tank is 15.625 meter cube. But how will you find the capacity? A cube. A cube, because it's a cubical tank. So capacity is A cube. A cube is equal to this number. But it's a decimal number. So we don't want a decimal. We'll convert it to a fraction. So how to convert to fraction? 1, 2, 3 places you'll have to shift. So by 1000. Because you'll have to move the decimal point by 1, 2, 3 places. So divide by 1000. Then simplify this. In the tables of 25, you can do tables of 25. 25. Actually, directly you can do in the tables of 125. Tables of 125 you can do directly, but we'll do 25 so that all of us know that. So 25 fours are 100 and 0. And here 25 6 are 150. 25 6 times is 150. 6 is the remainder. 25 twos are 50. 12 is the remainder. 125 now it is. 25 fives are 125. Then again the tables of 5. 5 eights are 40. 5 ones are 5. 2s are 10. 5s are 125 by 8. So you need to simplify completely. You need to simplify completely. So the simplest form of the fraction is 125 by 8. So A cubed is equal to 125 by 8. So A is equal to the cube root of 125 by 8, which is 5 by 2. Because the cube root of 125 is 5. Cube root of 8 is 2. 5 by 2, which is 2.5 meters. All right. So the edge of the cubical tank is 2.5 meters. The edge of the cubical tank is 2.5 meters. Now, what is the question? If the present depth of the water is 1.3 meters, the present depth of the water is 1.3 meters. What is the actual depth of the tank, children? What is the actual depth of the tank?
15.625 meter cube.
What is the actual depth of the tank?
1.3 meter.
Here Raja told us, right? 2.5 meters because it's a cube. Length is 2.5, breadth is 2.5, height is also 2.5. It's a cubical tank, which means the length is 2.5 meters, the breadth is 2.5 meters, the height is also 2.5. That means the total depth of the tank is 2.5 meters. If the present depth of the depth of the tank is 2.5 meters, but what's the depth of the water? Only 1.3 meters. So find the volume of water used from the tank. So what height of the water is used? 2.5 minus 1.3. 1.2 is used, correct? 1.2, that height 1.2 is used. 1.3 is remaining. Total height is 2.5. The total height of the water, the total height of the water, the total height of the tank is 2.5 meters. Okay, so now the present depth of the water is 1.3. 1.3. This is there. This water is there. To this height, water is there. The water is empty. 1.2 water is empty. There's no water. It's used. Correct? Okay. Now the question is find the volume of water used from the tank. How have I done it? Volume of the water in the tank. Water is cuboidal. Water in the tank is cuboidal. Why? Because it's not completely filled with water. Now it's become a cuboid. So L into B into H. Length is 2.5, breadth is 2.5, height is 1.3. Online students? Following?
Yes, ma'am.
Yes, ma'am.
If the tank is completely filled with water, water is cubical. If the tank is completely filled with water, it is cubical. Now the water has been used from the tank, and now the height of the tank is only 1.3 meters. So the tank is still cubical. The tank is still cubical. Water in the tank is cuboidal. The tank is not cuboidal. The tank is still cubical. The water in the tank is cuboidal. So L into B into H, 2.5 into 2.5 into height is 1.3. So this much of water is remaining. So what is used? The total capacity, 15.625 minus this. So this much is used. What is the other way of finding out? You can do it like this, or you can do it like this. Or what you can do is height of water. Yeah, height of water used. What is the height of water used? 2.5, total height 2.5 minus 1.3. So what is the height of water used? 1.2 meters. Correct? The height of the water remaining is 1.3. The height of the water remaining is 1.3. So the height of the water used is 1.2. Because 1.3 plus 1.2 is 2.5, the total height. So the height of water used is 1.2. So the volume of water used is equal to LBH. Somebody's mic is enabled. Please disable your mic. So it will be 2.5 into 2.5 into So 25 to 25 is 625. Into 10 is 6250. 625,250. 1250. 0057. Yeah, 7.5. 1, 2, 3 places. 7.5 meter. You can also do it like this. Understand, children? Please take down this R because you don't have it in your book. Please take down this R now. Yes, class, once again. What is the length of the tank? Online students. What is the length of the tank?
2.5 meters.
2.5.
What's the breadth of the tank?
2.5 meters.
2.5.
What's the height of the tank?
1.2.
What is the height of the tank?
2.5 meters.
Or if you say the same answer, what is the height of the tank?
2.5 meters.
2.5 meters. Now, what is the length of the water? What is the length of the water, children?
1.2 meter.
Use that 1 point. What's the length of the water in the tank?
2.5 ma'am.
2.5. Who said 2.5 now?
Sanjay ma'am.
Sanjay, yeah. Here also in the class, Raja and Arjun told us 2.5. The length of the water is 2.5. What is the breadth of the water?
2.5.
Yeah, 2.5. So the question is for the class, for you and the online students. Yes, 2.5. What's the height of the water now in the tank?
1.2.
1.3. Well, then what height of water is used? What height of water is used?
1.2.
1.2. So if you now you have to answer the question regarding water. Regarding the water, you will have to answer the question. So length of the, see here children, length of the water is, see the board, length of the water is 2.5, breadth of the water is 2.5. If you take the height of the water as 1.3, you will find the volume of the water in the tank. Because the depth of the water is 1.3. If you take the height as 1.3, you will find the volume of the water remaining in the tank. If you take the length of the water as 2.5, breadth of the water as 2.5, and height of the water as 1.2, then you will be finding the volume of the water used. Because you're taking the height as 1.2. 1.2 is used. So if you take the height as 1.2, you're finding the volume of water used. If you take the height as 1.3, you're finding the volume of water remaining. All of you get the difference?
Yes, ma'am.
Yes, ma'am.
All right. Finish that OR part, all of you?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
All right. Here, Arjun and Rajan. Now, usually Netra and Madhumita also come and sometimes Danya also attend the physical classes. Now, tell me for this week, when is the next class we have? Tomorrow we have? What time? Tomorrow we have from 7 to 9, is it? Okay, fine. So tomorrow you both will come physical. What about Netra will not come tomorrow physical?
Ma'am, I will come.
You will come, is it? Okay, what about Madhumita?
Ma'am, I won't be able to come tomorrow, but I'll come on Friday and Saturday. Ma'am.
Okay, what about Danya tomorrow?
Ma'am, I can't come to physical class this week.
Okay, and then who else? Here, you both? Tomorrow you will come. Then you said you will go on leave from? You're not able to come. All right, fine. The dimensions of a rectangular box are in the ratio 2:3:4. And the difference between the cost of covering it with sheet of paper at the rate of rupees 4 and rupees 450 per square meter is rupees 416. Find the dimensions of the box. Now see here, don't write anything, children. Don't write anything. Now see here. What will be the length, breadth, and height of the box? Length, breadth, and height, what?
2x, 3x, and 4x.
2x,
2x, 3x, and 4x.
3x and 4x.
Yeah. Now here, should you find volume or surface area? You're wrapping the box. You're wrapping the box with a sheet of paper. What is done here? You're covering the box with a sheet of paper. So is it volume or area?
area, ma'am.
Area. What area? Curved surface area or total surface area?
Total surface.
Yeah, total surface area. Like how you wrap your a gift box. You'll wrap it all over, all the 6 faces. So it is total surface area. So what is the TSC of the cuboid? 2 of LB. What is L into B? 2x into 3x. How much is it? 6x square. What is BH? 3x into 4x. How much is it? 12x square. And what is LH? 2x into 4x. How much? 8x square. Okay, so 2 of LB, 6x square, plus BH, 12x square, plus LH, 8x square. Correct? This is the total surface area. So it is 2 into 26x square. When you add all this, you will get 26x square. 2 into 26x square, which is 52x square. This is the total surface area. Okay, so this is the total surface area of your box. Now you are going to 2 shops. You're going to 2 shops. Okay, you're going to a shop where you see 2 different kinds of paper. You see 2 different kinds of paper. One paper is sold at the rate of 4 rupees per sheet, per meter, square meter, sorry. And the other paper is sold at the rate of 4.5 per square meter. So what will be the cost? What will be the cost? Area into rate. How much is it for 1 meter square? 4 rupees. How much meter square your box has? 52x square. All of you get it clearly. How much is the cost for 1 meter square? 1 meter square is at 4 rupees and 1 meter square is also at 4 rupees 50 paise. Now we'll have to decide which you have to buy. One is 4 rupees. Another one is 4 rupees 50 paise. 1 meter square is 4 rupees. See here, it's given rupees 4 and rupees 4.5 per square meter. So one is 1 meter square, 4 rupees. The other one is 1 meter square, 4 rupees 50 paise. What is the total area of your box? 52x square. Total surface area. What is the TSA of your box? 52x square. So what will be your cost? 52x square into 4 rupees. The other cost will be 52x square into 4.5 rupees.
50.
Is this understood, children?
Yes, ma'am.
If you buy this one, it is 52x square into 4 rupees. If you buy this one, it is 52x square into 4.5 rupees. So there's a difference in price, no? That difference is 416. You will pay more here. You will pay less here. If you go with this one, you will pay less. If you go with this one, you will pay more. That difference is 416. So that means this one minus this one is 416. This cost minus this cost, that difference is 416. Understood, all of you? Here you understand, both of you? Arjun, I'll tell you once again. Online students?
Yes, ma'am.
It's clear.
Yeah, now see the answer. So first find the TSA. First find the TSA, so that you know. Then cost of covering the box at 4 rupees per meter square. Cost of covering the box at 4 rupees 50 paise per meter square. Difference in cost is this one. So difference is this money minus this money is equal to 416. Work this and you'll get the value of x. Once you get x, you should find 2x, 3x, and 4x because you'll have to find the dimensions of the box. All right? Work this, children. Let me know, children, if you finished writing.
Completed, ma'am.
Yeah, all right.
Completed, ma'am.
I'm writing the last part, ma'am.
Yeah, fine. I'll wait. Arjun, you said you would share your answer paper, no? You didn't. You returned it then? You returned it? Your teacher? Yeah, you didn't share it at all. I think I asked you to take a printout and a Xerox and give it to me, no? Tomorrow without fail, along with the question paper.
Completed, ma'am.
Yeah.
Completed, ma'am.
Yeah. Where are you writing? Raja and Arjun? Difference in thoughts. Okay. One children. Boys are still writing here. 1 minute. Done, Arjun? You're stuck with the division, is it? 416 by 26? Yes, children. So see the next one. The sum of the length, breadth, and depth of a cuboid. 1 minute. Yeah. So the sum of the length, breadth, and height or depth of a cuboid. So sum. So we should add. Okay, is means equal to 19 centimeter. Okay, and the length of its diagonal. Arjun, what's the formula to find the length of the diagonal of a cuboid? Raja? Anybody online?
And root of L square plus B square plus H square.
Perfect. Root of L square plus B square plus H square. Children, we should have the formula. I told you the other day. When you're saying orally, it should be in your tongue tip. If you're writing, it should be in your fingertip. Root of L square plus, so length of the diagonal means root of L square plus B square plus H square is 11. We need to find the surface area of the cuboid. That means we'll have to find 2 of LB plus BH plus LH. Have I written it correctly, children? L plus B plus H is 19. Diagonally, so root of L square plus B square plus H square is 11. And 2 of LB plus BH plus LH we should find because total surface area we have to find. Surface area means TSA only. Now, when you look at these three, can you recall any identity? Any algebraic identity? It need not have all this which you see here, but somewhat related. Maybe it does not have the square root symbol. Without the square root symbol, you tell me. Maybe the algebra.
A plus B plus C the whole cube.
Whole
Square, ma.
whole square, yeah. So this looks like L plus B plus H the whole square. Expand this, Danya. What is L plus B plus H the whole square?
L square plus B square plus H square plus 2LB plus 2BH plus 2HL.
Correct. 2HL. When you take out 2 common, what will you get?
L square plus B square plus H square plus 2 in brackets LB plus BH plus HL.
Correct, children? So
Yes,
now we just have to substitute the values. So see here, L plus B plus H the whole square. So now this is nothing but TSA. This is nothing but TSA. Plus, what's the value of L square plus B square plus H square? Square this on both the sides. Square this one on both the sides. Square this on both the sides. What will you get? The square root is eliminated. When you square this on both sides, the square root is eliminated. So you will get L square plus B square plus H square is equal to 121. So what is this one? This is 121. This is equal to 121. And what is L plus B plus H the whole square? L plus B plus H the whole square. 19 square. 19 square, which is 361. So now TSA is equal to 361 minus 121. Correct? So TSA is equal to 240. 240. All right, do it. Okay, fine, fine. This is another way of working. This is also correct, but I'll just work again what I explained. 1 minute, children. I'll clear this and I'll work this again. Yeah, now write with me. So this, you should just leave this here and work. Just leave this here.
Functional.
Completed, ma'am.
Yeah. Finish, Arjun, Raja.
Completed, ma'am.
Yeah. So children, what we can also do is, see like this, you can presentation. You can also do it like this. The idea is the same, but you can work in a different way like this. So see here, LBH, L plus B plus H, L plus B plus H is 19. Diagonal is 11. That means root of L square plus B square plus H square is 11. Now, when you square this on both the sides, we get this one, 121. Correct? Now, I've taken up this equation, L plus B plus H is equal to 19. And I'm squaring this on both the sides. I'm just taking up this equation, L plus B plus H is equal to 19, and I'm squaring it on both the sides. What do you get when you square this? A plus B plus C, the whole square is equal to A square plus B square plus C square plus 2 of AB plus BC plus CA is equal to 361. So this one L square plus B square plus H square is 121. Plus this is the TSA is equal to 361. So TSA is equal to 361 minus 121. What is the difference between the two? Here I've not written the identity. I'm squaring this one on both the sides. I'm squaring this information on both the sides. So when I square it on both the sides, I get A plus B plus C the whole square. Then we expand A square, B square, C square, 2 of AB, BC, CA. You can do it like this. Or here what we did is we wrote the identity ourselves. We wrote the identity. L square plus B square plus H square plus 2AB, 2BC, 2CA is equal to A plus B plus C the whole square. We wrote the identity first. And then we substituted the values in the appropriate places. All right, children, you can do it either ways. Take down this also. You can say or and work it like this. Same idea. Answer is the same idea, but just that you're presenting in a different way.
Completed, ma'am.
Yeah.
Completed, ma'am.
Very good.
Completed, ma'am.
Yeah.
Completed, ma'am.
Very good. Find the number of bricks, each measuring. Bricks are cuboidal. You can see the length, breadth, and the height of the brick required to construct a wall. The dimensions of the brick, the dimensions of each brick is given to you. Length of the brick, breadth of the brick, thickness of the brick. Now find the number of bricks required to construct a wall. The dimensions of the wall given to you: 6 meters long, 5 meters high, and the wall is 0.5 meters thick. Dimensions: LBH. The length of this is the length of the wall. This is the height of the wall. This is the thickness of the wall, which can be taken as the breadth. Thickness of the wall is the breadth of the wall. While the cement and the sand mixture, yeah, to construct a wall, bricks alone are not enough. Now, supposing you have many papers, you have many papers. With the papers, you cannot make a book. You need glue, or maybe you need a needle and thread to stitch up the papers, or maybe you need what you can stick them, or you can staple them, or whatever. You need something else, right? Just with a bundle of papers, you cannot make a book. To bind the papers together, you need something else. Maybe a sellotape, or stapler, or whatever. So pages alone are not enough to make a book. So in the same way, bricks alone are not enough to make a wall. Simply, if you have bricks, you cannot arrange the bricks and say that this is the wall. You also need the mixture of cement and sand, correct? Why do you need it? To fasten, to bind the bricks together. Why do you need that? To bind the bricks, so that the bricks, like they're intact. So you need to splash the mixture of cement and sand, right? That's how it's done. The mason, what does he do? He splashes the cement and sand mixture, or maybe he rubs it. He splashes it first and then he rubs it. He evens it. Okay, so that the bricks are intact. So while the cement and sand mixture occupies 1/20th of the volume of the wall. Now, if I say that 30% of the class are boys, 30% of the class are boys, then how many are girls? 70% are girls. Now, similarly, in the wall, what are the two things in the wall? Bricks and mixture. Bricks and the mixture. These two things make the wall. Like a classroom is made of boys and girls, this wall is made of two things. What two things? The mixture. Don't say cement and sand. Together it's a mixture. The wall is made up of bricks and the mixture. If the mixture is 1/20, then what fraction is the bricks? 19/20. 19/20. If the fraction, the wall is made of two things. The wall comprises of bricks and the mixture. If the mixture occupies this fraction of the wall, then the bricks will occupy 1 minus 1/20, which is 19/20. This fraction of the volume of the wall. Is this understood?
Yes, ma'am.
Yes, ma'am.
If it's a percentage, we subtract from 100. If it is like 45%, then we say 100 minus 45, 55% is the remaining. When it's a fraction, 1/20 is 1. The other one is 1 minus 1/20. Because there are only two things here. So you can write it like this here. Volume of mixture is equal to 1/20 of the volume of wall. Volume of bricks is equal to 19/20 of the volume of the wall. Because volume of the wall is like the class. Volume of the wall is like the classroom. For 30% of the class are boys. 70% of the class are girls. So like that 1/20 of means into. What is the total here? The wall. Wall is the full thing. So 1/20 of the volume of the wall is the mixture. 19/20 of the volume of the wall is the bricks. Do we understand that, children? All of you understood this?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. Yes, ma'am.
Yeah, now I think you can take down the answer.
Completed now.
Yeah.
Completed.
Completed, ma'am.
Very
Completed,
good.
ma'am.
Yeah. So the important thing here is to have all the numbers in the same unit. So convert everything to the smaller unit, centimeter. That's very important. Convert all meters to centimeters. Done, boys? All I know, I'm not hurrying you up. Okay. Yeah. An open wooden box. Dimensions is given and the thickness of the wood is given. Now, before this, let me tell you something. Now, how do we handle open boxes and closed boxes? Okay, let me just give you a different set of values. Now, supposing it's a closed wooden box, closed wooden box. So supposing it's a closed wooden box, open wooden box. Okay, now the box, when it is when the wood is thick, it's a wooden box. So wood is thick, right? Wood is thick. Now supposing the thickness of the wood is say 2 centimeters. Thickness is 2 centimeters. Thickness of what? Thickness of the wood is 2 centimeters. So that means then the external dimensions will be different from the internal dimensions. Now think of the overhead tank. How is the overhead tank? It's mostly cuboidal, correct? The overhead tank is mostly cuboidal. The wall is thick, no? The wall is thick. Now, if you get, supposing the tank is empty, you get inside the tank and measure the length, breadth, and height. Outside the tank, you measure the length, breadth, and height. Okay. So definitely external dimensions will be more, right? Because the wall is thick. External length will be more than the internal length. External breadth will be more than the internal breadth. Similarly, the external height, because when it's a wooden box, now when it's a wooden box, wood is thick. So the external height will be more than the internal height. Inside the height will be slightly less because the wood is thick, no? Sorry? That's what, the wood is thick, right? Wood is thick. So when you, difficult to draw for me, that's the problem. Have you seen wooden, anything wooden? On the outside, the height will come from here, from the bottom. But the wood is thick, right? At the base of the box, the wood is thick. From outside, if you measure, you will take the total height. But from inside, if you go inside the box and measure, the base of the box will be thicker. So the height will be slightly less. If you jump inside the box, the wood is thick. At the base of the box, the wood is thick. So the internal height will be less. When you come out of the box, the height will be more because the thickness of the wood is not there. The height will be slightly more. So when the material is thick, now here the box is made of wood and wood is thick. So the external dimensions will be more than the internal dimensions is the first thing. Now let us find the internal external dimensions. Supposing the external dimensions, I'll say capital LBH, okay? Okay. So when I've written when I've used capital LBH, it is the external dimensions. External dimensions. Now, what will be the internal length? What will be the internal length? You'll have to subtract the thickness of the wood on both the sides. You'll have to subtract the thickness of wood on both the sides. So what's the thickness of the wood? 2 centimeters. So the internal length will be 70 minus 2 on this side, 2 on this side. 2 plus 2, 4. So 70 minus 4. The internal length will only be 66 centimeters. The internal breadth, the breadth, again, 2 centimeters thick. So on either side, 2 centimeters gone. So minus 4, 50 minus 4, 46 centimeter. It's a closed box. It's a closed box. So height also, bottom 2 centimeters, top 2 centimeters. It's a closed box. So the internal height will be bottom 2 centimeters, top 2 centimeters gone. So 20 minus 4, 16 centimeters. In the case of an open box, the height only will be different. The length will be the same, 66 centimeters. Breadth also same thing, 46 centimeter. What you got here? The height will be 18 because only in the bottom you should subtract the thickness. Top is open. Top is open. Very good. Top is open. It's open, right? So the height will be 20 minus thickness only once. 18 centimeters. Is this understood, children?
Yes,
Yes,
ma'am.
yes, ma'am.
Yeah. So when it is thick, you know, to find the internal dimensions, you must subtract the thickness 2 times because either side we'll have to take it off. For length, breadth, height, you should be careful. If it is closed, then you should take away the height, the thickness 2 times. If it is open, only once. You should subtract thickness only once. That's all. Once you have the dimensions, it is easy to answer any question. Okay. Now coming to this question, it is an open wooden box. Okay, it is an open wooden box. An open wooden box is 80 centimeters long. When they say this, your question is it internal or external? If nothing is mentioned, it is external only. Because how will you measure a box? Outside only you measure, no? If I leave a box there and ask you to measure the box, we'll measure. If I don't say anything, then you will say, okay, she didn't say anything, so mostly external only. If nothing is mentioned, external it is, not internal. Okay, so what is L? 80 centimeters. What is B? 65 centimeters. And what is the external height? Internal length?
75 centimeters.
Internal breadth?
60 centimeters.
60 centimeters.
Internal height?
40 centimeters.
42.5 centimeters.
42 minus 2.5. So it will be 42.5 centimeters. Because it's an open box. Subtract the thickness only once. 42.5 centimeters. Now, how do you find the capacity of the box?
Volume of the box, ma'am.
This one, capacity of the box. Yes, well, just 1 minute. Students, yeah, just tell me this into this into this, like it's cuboidal, right? It's cuboidal.
So it's length into breadth into height, ma'am. 75 into 60 into 42.5.
Why are you taking this one and not this one?
Ma'am, because we can fit things only inside the box, ma'am.
So tell me now.
Because the capacity of the box is we can't store anything inside the thickness of the box. Can at least put it inside the.
Yeah, very good. Yes, Raja answered here in the class and Madhumita. So capacity of the box means what the box can hold. And where will it hold? Inside, no. Then capacity of the box means you should use the internal dimensions. Because capacity means you're going to store something inside the box. Where will you store? Inside the box. That means you should take the internal dimensions to find the capacity of the box. All of you understood?
Yes, ma'am.
Yes, ma'am.
Yeah, to find the capacity of the box, you should not take the external dimensions. You must take the internal dimensions. Inside, if you look inside the box, it's cuboidal only. And there only it's the capacity, because you're going to, store things there. You should take the internal dimensions to find the capacity of the box. Next, children, volume of wood. Volume of wood.
Ma'am, the external volume.
One second, Madhumita. Yes, yes. Raja already started saying yes. Perfect, very good. So Raja gave the correct answer. Yes, Madhumita, please continue.
Ma'am, we should subtract the internal volume from the external volume.
Correct. Subtract the internal volume from the external volume. Very good. Madhumita and Raja, they're right. So the volume of the wood will be the external volume minus the internal volume. Just imagine that the whole thing is a cake. And you eat off that cuboid which is inside. Inside, whatever is open, that portion you eat. So what is remaining is the wood. So it is the external dimensions minus the internal dimensions. Capital LBH minus small LBH will be the volume of the wood. Next, you should find the weight of the box. If it is given that 100 centimeter cube of wood weighs 8 grams. So you found the volume of the wood. So the weight of the box will be into 8 by 100. Into 8, because 8 grams for every 100 centimeter cube. 8 grams for 100 centimeter cube it is. So for 1 centimeter cube, it will be 8 by 100 grams per centimeter cube. It's 8 grams for every 100 centimeter cube. So for 1 centimeter cube, what will be the weight? 8 by 100 grams per centimeter cube. See, if I say that something costs 500 rupees for 100 copies, for 100 copies, rupees 500 for 100 copies. That means how much is it per copy? 5 rupees, because rupees 500 by 100 per copy. 5 rupees per copy. Similarly, 8 grams for 100 centimeter cube. So for 1 centimeter cube, it will be 8 by 100 grams. Yeah. Yes, children, please work.
Completed, ma'am.
Yeah, good. Any doubts? Any questions, clarifications?
No doubts, ma'am. It's clear.
All right.
Completed, ma'am.
Completed, ma'am.
Yeah,
Completed, ma'am.
Completed, ma'am.
very good. All right. Raja done? All right. Yeah, I think this you can do it yourself. I'll just send this picture in the group. You can work this as homework. Children, this image I've sent in the group on WhatsApp, very similar to the earlier one. You can help yourself. Yeah. Write down this question. Just know you write the question and leave some place so that you can complete the answer later. Write down this question, children, all of you. The homework question, all of you, write down.
Completed, ma'am.
Yeah.
Completed, ma'am.
Complete, ma'am.
All right. You're doing something. Yeah, children. Leave some space to complete the earlier answer and take down this question now. We are working this now in the class.
Completed, ma'am.
Yes, children. Now, don't write anything. We'll first understand and then you can write down. So we have the closed rectangular wooden box. Okay, now tell me for the box. Tell me what is L? You should understand when I write capital L, it is external length. If I write small l, it is internal length. Yeah, what is capital L?
18 centimeters, ma'am.
18 centimeter.
B,
10
10
centimeters.
centimeter.
H,
6
6
centimeter.
centimeters.
L,
17.5 centimeters, ma'am.
go.
17
17.
centimeters, ma'am.
Raja was right. Okay, now Madhumita, you're also right. Because you'll have to subtract 0.5 from both the sides. It is a closed box and the external dimensions are given. Internal dimensions, length is 18, external length, minus 0.5 on both the sides. Half is 0.5, 0.5 on each side. So 1, 18 minus 1, 17. What is the value of small b?
9 centimeters, ma'am.
9 centimeter.
Small h?
5
Five.
centimeters.
5.5 centimeters.
Because it's closed. So you'll have to subtract the thickness 2 times because it's closed. Okay, so for box, we have everything. All right. Now, when the box is empty, if the box is empty, what will weigh? Weight accounts to what? Wood
Weight
in
of
the
the
box.
wood, ma'am.
Correct. The weight of the wood. When the box is empty, meaning what is giving? How is it 15 kgs? It's the weight of the wood. It's the weight of the wood. The box is empty. Then how is it heavy? How does it weigh 15 kgs? Because the box itself is heavy. The wood is heavy. Correct. So the weight of the wood. Weight of wood. Weight of wood is 15 kgs, correct?
Yes, ma'am.
Don't work, children. All of you, please listen to me. Weight of wood is 15 kgs. Now, how will you find the volume of wood?
External dimension minus internal
Plus
dimension.
internal
ma'am.
dimension.
External volume minus internal volume. Volume of wood. Volume of wood is equal to, see, weight of the wood is 15 kgs. Volume of wood will be external dimensions minus internal dimensions. So it is what, 18.6, how much is 18.6? 6 8 48, 8 4 carry over. 126, I think it is this. This is the external volume minus the internal volume. 17 into 45. 5, 8, 28, 2, 6, 765. I hope I'm right. Please check if I'm right, children. I'm subtracting with 5, 9, 1 minus 7 is 4. Please tell me if I'm right. Or 1 minute, I'll just check here. 315. 1080. What did I multiply? 18, 6, 6, 8, 48, 4 carry over. 1080. No, I know I am bad at multiplication, addition, subtraction. I know I'm bad. Okay, I'm just taking the answers from there. Okay, so this is the volume of wood, children. 315 centimeter cube is the volume of wood. Now, how do you like, use this? We have the weight of the wood as 15 kgs and the volume of wood as 315 centimeter cube. So see here.
315 by 15 gives us the weight of 1 centimeters. 1 centimeter.
Centimeter cube of wood. Very good, very good. Yes. 300 centimeter cube is the volume for 15 kgs. Then for 315 centimeter cube of volume, the weight is 15 kgs. For 1 centimeter cube of volume, what is the weight? I'll make it more easy for you. 1 minute. See here. If 315 centimeter cube is the volume, the weight is 15 kgs. Is asked to, if 1 centimeter cube is the volume, what is the weight? Do we understand this? So that answers the first question, the first part of the question. Find the weight of 1 cubic centimeter of wood. Find the weight of 1 centimeter cube of wood. And then 1 centimeter cube of sand. So we have to find the weight of 1 centimeter cube of wood. That's what we're finding here. 315 centimeter cube is 15 kgs. Then 1 centimeter cube is how many kgs? So how do you work this? 315 into x is equal to 15 into 1. Do you know product of extremes is equal to product of means? Okay. Okay, then write it like this. 315 by 15, because ratio, no, is equal to 1 by x. All right. So cross multiply. 315 into x is equal to 15. X is equal to 15 divided by 315. So 15 ones are 15. 15 twos are 30. 15 ones are 15. 1 by 21 kgs. So 1 centimeter cube of wood has a weight of 1 by 21 kilograms. All right. Now next we have to find the weight of 1 cubic centimeter of sand. So what is the volume of sand? How will you find the weight of the sand?
Ma'am, it's the inner volume.
Correct. To find the volume, it is, yes, Raja? Internal volume is the volume of the sand, correct? The volume of the sand is the internal volume of the box. Because where do you put the sand inside the box? which takes up the internal dimensions. So the volume of sand is equal to the internal volume of the box. Okay. So what is the internal volume of the box? So it's 765, no? 765 centimeter cube is the internal volume. And what is the weight of this one? What is the internal volume of the box? It's the volume of sand. Volume of sand is equal to 765 centimeter cube. Now, what's the weight of sand? What's the weight of sand?
100 kgs, ma'am.
Oh. Very good. Raja gave it right. 100 minus 15. 85 kgs. 100 minus 15, 85 kgs. Because the box itself has a weight of 15 kgs. The box itself weighs 15 kgs. And when you fill it with sand, it weighs 100 kgs. That means the weight of sand is only 85. 85 plus 15, the total weight is 100. Yes or no, children?
Yes, ma'am. I thought the weight of the sand was given to us directly, ma'am.
Yeah. So when the box is filled with sand, when the box is empty, it weighs 15 kgs. And when filled with sand, it weighs 100 kgs. When you fill the box with sand, it weighs 100 kgs. How do you get weight as 100 kgs? 15 plus 85 is 100. 15 is the weight of the box only. So 85 is the weight of the sand only. Put together is 100. The weight of sand is 85 kgs. So like this, again, you have to work. How should you work? 765 centimeter cube is 85 kgs. Then 1 centimeter cube is how many kgs? All right. So like this, we find the weight of the sand and wood per cubic centimeter. Yeah, right on, children.
Completed, ma'am.
Okay. Done, children? Raja and Arjun? Last part? Finished. Oh. Online students?
1 minute, ma'am.
Yeah.
Completed, ma'am.
Done. Any questions? Will you see it again? So we have the external dimensions and the internal dimensions, correct? So what will be the volume of wood? Volume of wood will be what? External volume minus internal volume. What will be the volume of sand? Only the internal volume. Only the internal volume. Volume of sand is only the internal volume. Volume of wood is external volume minus internal volume. So what's the volume of wood? 315. And what's the volume of sand?
765.
765. All right. Now, how do we proceed? We need to next find the weight of each. What's the weight? We have the volume now. The two things in the question are wood and sand. We found the volume of wood, external volume minus internal volume. And we found the volume of sand. Now let's find the weight of wood. What's the weight of wood? What is the weight of wood? $15 kgs. Are we all there, online students? Weight of wood is 15 kgs. What's the weight of the sand?
Weight of the box with sand.
Weight of box with
That's
sand
about
minus weight of box, empty box.
100 minus 15, 85 kgs. Weight of the sand alone is 85 kgs. Weight of the sand alone is 85 kgs. So what do you have? Volume of wood, weight of wood. Volume of sand, weight of sand. Now what will you write? 315 centimeter cube of volume has a weight of 15 kgs. Then 1 centimeter cube will have a weight of 15 by 315. Yes or no? Kgs per centimeter cube. Per centimeter cube because for 1 centimeter cube it is. Because it's for 1 centimeter cube. Similarly here, 765. Here 765 centimeter cube has a weight of 85 kgs. then 1 centimeter cube will have a weight of 85 by 765 kgs. All right. So it's a very simple one. It just depends on how you understand the question. Clear, children?
Yes, ma'am.
Yes, ma'am.
All right.
Yes, ma'am.
All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. Good night.
Thank you.
Good night. Thank you. Yes,